Alright, welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. We are still developing unassemblize tool. There is still a lot of stuff to do, but we already also completed a lot of things. We are still here. Last video we dropped off with the look ahead matching. Look ahead instruction matching. So now the idea was to put this guy here into a function and then call it twice for either side. Okay, let's try to draft this. Let's see. Look ahead. Oof. Okay, so yeah, let's put a function here first. Let's do void look ahead compare. I think it needs to return boolean. Look ahead compare, and there will be a bunch of arguments. Okay, so okay, there's a lot of things going on here. Look at limits. Okay, look ahead limit, what was it? Size T, right? Yeah. Okay, so we need a size T look ahead limit. Okay, look ahead limit. We also need instruction 0. We need look ahead. Okay, instructions. Shit. I think we need to give it Oh, this is already complicated enough here. Maybe it shouldn't be in a function. It's just too complicated. Because there's just so many little things. Maybe we should just try to make this more readable to begin with. Oh boy. Okay, let's go through it once more to get it back into our memory. Look ahead limit. Mismatching. Oh. Look ahead. How about we rename this to arrays? And this is empty array. I'll call this array 0, array 1. Then we do look array. Basically, I want to have shorter variable names, which then probably makes it easier to look at. Look ahead. We already have a mismatch detail here. I would like to try this anyway. occupies. So it would be nice if you would just pass it. Maybe just pass it a range. We don't have std span here, but we can give it. We can give it an iterator. Begin. And oh, but there's so many different things here at play. Okay, there's also this result thing. Results. We probably need a struct look ahead results. What? Look ahead results. And here we probably need something like is matching. Look ahead results. Comparison results. Look ahead results. So you would say bool. Oh. Look ahead result is matching true. Look ahead result is false. Okay, look ahead result, bool is matching, bool is label false, false. Look ahead results. Dot is label equals true. Return look ahead results. Then we remove this. Okay, so here end is pass. Okay. Assert begin is not end. How about we do first, last? Maybe that's better. First is not last. I say as first is, yeah, it's not last. Maybe can make even a smaller. Yeah. Then we do last. And we need to give instruction array 0. Instruction arrays. Let's clean up a little bit here. Arrays. Array 0. Arrays. last. So I think we need a const last array. Okay, so last look ahead. Last array is this one here. Then we also need opposite. Let's say compare array. Last array, compare array. Okay, so here we do last array. No. Last array, compare array. And then we remove this. Let's call this first. First instruction. Last instruction. Okay, so here, last instruction. Look ahead, result is label. Look ahead, result. Okay, look at mismatch detail. Let's call this just mismatch detail. And then here, if it's matching, then right. So let's do this. Let's do first instruction smaller equal last instruction plus plus first instruction. let's prefix this with IT. Iterator. Or postfix. Last instruction. IT. Let's do auto IT equals first IT. IT smaller equal this plus IT. Then here IT label. Okay, we also need look ahead limit. We also need size T side. Or side. So if this is side, okay, so side that, so assert side equals 1, 0, or side equals 1. Sides, here side, let's do size T let's call this look ahead side, look ahead side. Then we do another concise T look compare or other side other sides 0 1 otherwise 0. It's probably easier way to write this. Look at can probably do look ahead plus 1 modulo 2. So that would be, if it's 0, it will be 1. If it's 1, it will be 0. Yeah, good. And then, so look ahead side here, and other side we do this Same here, look ahead side, other side. It's matching. Okay, let's see. I'm a bit suspicious about that. Look at compare. Okay, we don't need look ahead limits. Look at results. Okay, we need to put this guy in here. Look at results. And then we need to put this down here. Maybe we rename this to run look ahead comparison. Okay, so this function is all good. Let's go through it. So you can simplify this to smaller too. Okay, other side, yeah. It's dummy instruction. Okay, here we can rename this to just label. ++ IT variant. Instruction 0. Layer. This label is matching. I think we can omit this because the default is already false. Okay, so basically what it will do is it will check if it's a label, and if it is, just sets this. Otherwise, it does a comparison, and if it is matching, then it will also populate the comparison results with labels or mismatch. And then it will say it is matching. Yeah. Okay, I think we can work with this. Look ahead. Side is matching with look ahead. Look ahead instruction look ahead instruction is matching with base instruction on the other side. Okay, maybe we should rename this to, let's rename this to look ahead IT. And this is look ahead last let's call it look ahead base IT. Look ahead base. This is look ahead last array, and this is other base array. Let's call this maybe opposite base array. Then we call this opposite as well, opposite side. Let's make a comment here. Look ahead refers to the side that is looking forward the instruction. Look ahead refers to the side that is looking forward the instructions to compare to the other sides. Opposite refers to the side that look ahead refers to the side to the opposite side. Maybe we can describe this differently. Looks ahead one side of the instruction. Looks ahead one side of the instruction list and compares the last entry with the base opposite entry. Looks at one side of the instruction list and compares its last instruction with the with the base instruction of the opposite side. Looks ahead one side of the instruction list and compares its last instruction with the base instruction of the opposite side. I think that's a good description. Oh boy. Okay. So let's comment this out and this here. And now we need to call this thing and make it work. So we have look ahead results. Look ahead results equals, okay, let's just call it first with all the required arguments. Look ahead base last. Look ahead last array, base array, comparison result, look ahead side. Okay. Okay, so look ahead base IT. That will be instructions 0 dot begin plus I0, right? That's our base. Yeah. Maybe we ASM instruction vector iterator base. I like to make it easily readable. Base last. So that would be begin. That would be base plus K0. What's the problem here? Does it have to be const? Const iterator. Yeah. Const. Okay, so this is base last. Good. Next, look ahead last array. Look at last array. That is, let's call this base IT. Base IT, last IT. Then run look ahead comparison. Base IT, last IT. Now we need this one here. Erase 0. So this will be this. Const, what was the name? Look ahead, last array. Okay, So we call it last array. Let's also put the zeros here to have no doubt about it. Okay, so we pass last array. Okay, then opposite base array. Opposite base array. That is array 1. And then the comparison results, that is this one. And look ahead side, so this is side 0. Okay, there is some error. It's not static. Now it is. Okay, so this would work. Okay, and now we need to make some checks. So if look ahead result dot is label, then we do these things. Continue. Do we need continue? Yeah, I think so. If it's label, continue. Yeah. Otherwise, else if look ahead result is matching, if is matching, then we set is matching equals true, and we increment I0 with K0. And then we break. Otherwise, we increment K1. Okay, but then we don't need this continue thing. Oh boy. Okay, let's we need to do mental gymnastics. It's quite a complicated flow, I have to say. Okay, so we have a base IT. This is our site, our look ahead site instruction, site 0. Begin plus I0. That's our base. Last is base plus K0, which will be 1. At least 1. So the assert inside the look ahead comparison, this one should never hit this assert. Then it does its thing, which we will get to. So the result is, if it's a label, then we increment K0, yeah. We skip overhead. We skip over it. And we also increment our look ahead limit because it wasn't a legitimate instruction. So we want to look a little bit further, one further for every label. Good. and then these won't hit. Need to remove this here as well. So these won't hit. So if it's not a label, then it would check if is it matching, and if it is matching, it sets is matching to true, and then it changes I0, which is our base index. It's K0 because that's where the match is, and then it breaks out of this loop. Otherwise, it increments K1 to then look at the other side. Let's make a comment here. Increment opposite side. Increment opposite side index to look at next. So skip over label. Return on match and reset base index and update base, update and set new base index on return break. Well, set new base index. Set new base index and break. Okay, I think it's correct. Maybe. Okay, let's remove this here. Well, let's also comment it out for now. Oof. Okay, so here it will be now the base, the same thing. Maybe we should. Ah, sorry, look. Maybe we should remove the 0 from here. That's array. Okay, so basically we need to take all this now, put it here, and then we need to change all these little numbers here. Okay. Okay, I hope this is correct. I think this is better as like a duplication instead of all this. It's quite big. So I think this is not bad. Okay, look ahead side this. Look ahead base IT. Look ahead last array. look ahead side. Maybe we should put the look ahead side here first. Zero. Oh, this should be 1. This is 0. It's easy to make mistakes here. Okay. 0, 0, 0, 0, 0, 0, 1. 0, 0, 0, 0, 1. 1, 1, 1, 1. 1, 0. 1, 1. 1, 1, 0. Yeah. Skip over a label. Look at which side is label. Skip over label, and yeah, this is enough. Maybe we should also name this look ahead here. Look ahead base IT. Okay. Oh, what do we have here? Redundant code. Needs to be a 1. Yeah, good. Thank you, Visual Studio. Oh boy, this is quite a complicated flow, I have to say. Yeah. Okay, so this will be now a first time compile. I think we also need to update our argument names here. Look at base IT, last IT, last array, opposite base array, and comparison result. It would actually be nice to write it like so, but it doesn't allow us. Let's do clang minus format of it's much easier to read this way. Oh, I hate this clang format bullshit. It's retarded. Should never use it. Yeah, it's much easier to read. Okay, we still have some zeros here. Label. Maybe we should move this here. I'm a bit confused. Why is here ASM mismatch? Ah, right. I wonder if this is correct. If it's because if we the last IT is matching now, so we shouldn't be doing this, you know. I think it has to be like this. Because if we reach the last IT was what was compared here to be matching. So the last one is not a mismatch. Or am I missing something? Look at last. Look. I think so, yeah. I think this is correct. Should we write smaller or not equal? I mean, it's a vector, so we can use smaller. Operator. Okay. Let's do auto, it's okay. Okay. I hope that this is correct. Okay, before we debug here though, we have to... Yeah, we first have to... Let's compile this first. We haven't compiled in a while, so there could be error still. Yeah. Instructions. Okay, that was simple enough. Okay. And breakpoints. Yeah, okay, so first we have to check if this actually still works correctly, because we have touched that. Let's see. Instructions, count, label count. Oof. Right. So we reserve to 11487. 11487. 11.7. Okay. Then if there is a label, creates this, sets a name, and it adds this label. Okay. ASM instruction address. Okay. Status. Text. Okay. Jump type none. Instruction and place. Okay. Okay, let's let it run through. Instructions 11200. That's more than, was it? Hold on. We had 11487. 11487. This is less. Why? Maybe because it's already added. Let me see. Bool. Add pseudo symbol. Bool. Return false. Bool. Edit. False. Edit. True. Return edit. If let's see if that suppresses a count to 1200 or 11,200, whatever it was. Oh. Not all control paths return a value. Oh, I see. ahead last IT. Else asserts it's not null pointer. Okay. So now we have much less than 1100, 11200. So it ends up having 11194. Which is now less than before. What? How's that possible? Okay, it varies. There's some randomness in there. That's weird. It's weird that something is not deterministic inside this. It's strange. Okay, so somehow we get way more entries here than we have initially reserved for. And this is how we get this over capacity here. Why is it? Ah. I think it's because some of the symbols are known already. And therefore, how can we optimize this? At least that matches. I don't know. Can also say if IT is not int, turn false. Turn true. Well, I mean, if this is not reliable, then I guess we have to over reserve a little bit, which is not the end of the world. So 11484. So it's almost 300 over. Maybe there's one more thing we can try. We add pseudo symbol result, or we make it a enum class pseudo symbol result. So the symbol result edit is executable, or let's say add pseudo symbol result, edit. But I think that won't work either. No, I don't know. Das Label before we had like a perfect sizing for this, and now we don't. Yeah. Sweetest. Yeah, no idea. We would essentially have to make a second, another pre-pass to get the label codes. It would be nice to compute this somehow, but I don't know how. How can we compute this? There must be some way. No, there must not be. Well, there is a way, but then we have to do this pre-pass. Here's some instruction label. Think. I can't do another pre-pass. That's too expensive. Yeah. I don't know. I don't have a good idea how to pre-compute this. Even this, like this, is fishy because it's not accurate, and if it's not accurate, it's not good enough. I mean, this instruction counter is good, but label count is totally off. Totally off. It would have to. So what is missing here, for example, are the function labels. What if we do setup and executable, get symbol, if not symbol, then return, no, not return, label count. Oops. Maybe. Oh, that looks pretty close. 11197. That is, how fast is this function? Oh, it's just looking on a hash map there. It should be pretty fast. Maybe. Okay, so I have the suspicion that the size will be now one less than this. Let's say. Two less. Huh. Okay, I don't know why it's two less. Let's put this to 0. Okay, so now it reserved 11197. And we get one less. I mean, it's pretty accurate. I don't know why it's one less than what we have reserved for. But seems to be okay. I just wonder if this is now more expensive than like over reserving and then shrink to fit after, which could also be just fine, right? I don't know. Looks like we can do this. Yeah. Yeah, let's leave it like that for now. Good. Let's continue execution. Okay, now it gets interesting. Good. So we have instruction 63, 489. Yeah. So there's a label. Lock. Is jump equals true? Huh? Why are all these things jumps? Okay, I have no idea what's going on there with all these jumps. That looks wrong. Yeah, something is not right. Right, it's uninitialized, that's why. Well, in that case, then maybe... Yeah, maybe we should create a constructor for it after all. I don't think we can set this to 0. Yeah, it's kind of weird that this is not allowed. So is jump equals false? Is invalid equals false? Jump len 0. Address is 0. Well, if we do this, then we also don't need this here anymore. Okay, let's see what we have now. Is jump false false? Yeah, this looks more realistic now. Okay, that's fair. Let's check if our print still looks good. Oh, there's some spaces here. Mm. Okay, let me see. Function. Ah, yeah. This is why. No, that's a long name here. Okay. This looks suspicious. Oh no, there is a red. Wow, that's weird. It's just empty. Okay. Interesting. Okay, it looks okay on first sight. All right, so we have our instructions. Now, the moment of truth, checking what we have done here. I expect many errors. How about we decrease this to 4? Maybe that's sufficient. Maybe we pre-compute all instruction splits to avoid redundant splits when visiting instructions multiple times. Why is pre-compute not a valid word? Why is English? Does it have to be pre minus compute? I don't get it. How is pre-compute no longer a word? Recompute. Create all instruction splits to avoid redundant splits when visiting instructions multiple times. Good. Okay, so 63, 489. Now where we edit, we can also add a assert here. Well, let's put an assert in here. Assert Ah, it's not necessary. Resize guarantees it. All right, empty array. Okay, so count 0, count 1. Lines reserve max. Reserve max. That or that. Okay. Okay, is matching is true? Why do we initialize with true? Ah, we explicitly set it false. See. Good. Look ahead also true. Array 0. That will be the label. Okay, so it first starts with labels here. Mismatch detail, not mismatching. Now this is actually an unnecessary compare at this point if it is a label, right? It's a mismatch detail. How about we move this guy here? We move this here. Compare instructions. But it's still yeah, I guess it's fine here. I mean, it strictly is not necessary to do mismatch detail when one of these would be null. This function is quite something. It's quite hard. Okay, so count 0, count 1. Look ahead, mismatch detail, variant 0, variant 1. Good. So both are labels. So it sets label here. And it sets a label here, increments both, and plays back this thing. And so our first entry will be a line with 2 labels. And then we continue. Good. Mismatch detail. Good. Then next will be no labels. So it jumps over here. Then it compares instructions and mismatch bits. Set it to. And let's look at these guys. So this one push ECX. And this one is push EBP. So bit 1 is number 2, yeah. So mismatch detail is okay. Mismatch detail. Maybe we should call this maybe we should just call it mismatch bits. Mismatch bits. Okay. So here, not this jump, mismatch bits is matching false, look ahead true. Yeah. Okay, now it's getting interesting. It's the first time we look in our look ahead. Let's put a breakpoint here for next time. Let's remove the breakpoint here. Okay, so it's looking ahead and trying to find if something up ahead is looking similar. So, okay, yeah, it's bigger. Look ahead base. Look ahead base is right. Look ahead base is where we're at right now, right? Yeah. Okay. And last is one forward. So move dword PTR. Let's check if this actually is true. Win main, where's win main? Oof, win main. Here, push ECX and then move dword pointer critical section. Yeah, critical section here. Okay. Okay, so this looks correct to me. And then we do look at last array. So this should also be a critical section thingy, yeah. And we have a look ahead result. It is not a label and is not matching. Okay. So we will increment K1. Good. So now next iteration, it should go in here. Yeah. Let's go into the look ahead comparison. Look ahead side, smaller that, yeah. Opposite side. So look ahead side is 1, so opposite must be 0, yeah. Look ahead results. It is not a label. Assert this. Mismatch detail. Look at last array. Move EBP ESP. EBP ESP. Opposite base array is push ECX. Yeah. Mismatch detail. Mismatching is matching. It's not matching. Look ahead result. Okay, and then now it keeps on going. Just doing that. Yeah, okay, this looks correct so far. How about we put, let's put some breakpoints in here. When it's matching, we would like to see what happens. So that when I look ahead, will be matching. That would be interesting. And when And I guess we can also check what happens when it's a label. Here is label. Let's put a breakpoint in there as well. Okay, so we got a label here. Is label true? And then it returns. Is label, so K0 is 18, limit is 20. It increments this guy and the limit. Yeah, that's fair. Okay, this seems to be fine. We have got another. Okay, so that was done. It didn't find the look ahead. Okay, let's put a breakpoint down here to see where this is going here. Okay, so now what is the result here? Is matching is false, so there was no look ahead match. That means we now go in here and the instruction is subsystem interface and this. And it's a mismatch. And that's a mismatch. Mismatch detail. Yeah. Okay, let's put a breakpoint here. No. Here. Let's remove this one. Okay, here we have something is matching. Okay, that's interesting. So K1 is 19. Okay, so there's some look ahead matching. Whether or not it will make sense, we don't know. Label. Instruction. Push. -1. Okay. Okay, seems to do what it should do. Maybe. Okay. So far, I mean, it runs through without crashing. That's already a good sign. It's not crashing, it's half done. Okay, let's remove the breakpoint here. And they've got a crash. Oh boy. Okay, well, I was a little bit too ambitious here. Okay, what's the problem? Is matching true? And here we got an invalid. Wow, okay, interesting. So I1 plus K1 count variant lock. What? Okay. Okay, that is unexpected. Yeah, didn't anticipate this problem. Interesting. So that means there must be some hard error somewhere. Okay, I122. That refers to a label. How can that be? Like, because it says is matching, but clearly this thing is not matching this thing. How is this? How can this be? So I0 is 3, 19. Ah. Isn't it wrong to use K here? Because we have already baked it in here. Right? Yeah. I think using K is wrong here. So it should be just like this, I think. Yeah. Let's try this. Because the K is only temporary here. Okay, that also means we should move it down here. Man, this stuff is complicated. Okay, so now I1 is matching false. 2, 2, 3, 22. Right. So this should now be matching. Let's see. Move the DMA critical section. That's not matching. Hold on. It kind of is, because it ignores the strings. Mov dword pointer offset. Let's say mov dword pointer offset. Yeah. So actually it is correct. It skips over the unk, right? It has a lax comparison if its symbol is unknown. So this is actually correct. This is correct, yeah. Now, whether or not the comparison is super clean, that's another question, right? But as long as the algorithm works the way we have designed, it's all good. I like it. Good. So this is then working here. Is a match. Instruction pair. Move Yeah. Okay, this is cool. So what it does now, it has skipped over a whole bunch of lines. So I0, what is I0? I0 is hours. I0 is the smaller one. This is a bigger one. Yeah. Okay, that's very interesting. Let's put a breakpoint here and here. And we got another crash. Holy shit. Okay, it's mismatching. Huh. Okay, it hits this assert. Look ahead. Why? Is... Do look ahead. Does it need to be false? Yeah, it needs to be false. Look ahead needs to be false. Is matching... Maybe we should do here else. What the hell? What? Else is matching equals true. And we also set this matching to false. Always good to initialize with zeros. Okay, so is matching true, and then we remove it from all these guys here. Look ahead, look ahead, look ahead. Let's make a comment here. Look ahead makes no sense then. Okay, let's try this again. We are crawling through the errors one by one. It's easy to make mistakes here. With a function this complex. Ah, okay, now we got a bunch of matching ones. Look at that, that's cool. Let's see. Yeah. Yeah. That's pretty cool. And then we got a mismatch again. Why? Call init memory manager, and here it does mov. Okay. Call weapon test. Call get module file name. Oh, it's definitely not the same. Here we got another XOR. XOR. Okay, that's cool. Okay, that seems to run now. Yeah, we get a result. is matching false. So we got a bunch of matching ones in here. XOR, XOR. But the most are mismatching. It tries its best to find those things that match. But it has a hard time here. Push EAX. Okay, well, something is matching here. Uh-huh. Okay. That is pretty cool. This looks very, very promising. Let's see some more functions. It's matching false. Okay, so this one has a lot of stuff matching. So index 1 means it's matching. Index 0 is label, and index 2 is mismatch. Okay, so here something is mismatching. The jump distance is mismatching here. No. What is mismatching here? Is jump. Huh? This should be the same, huh? Why is this mismatching? I don't understand. Both are jumps. Let me put that in the watch. Oof. Lines. It was 16. Value. These things should match. They have the same length. They are both JZ shorts. Should be. Oh, because lock. It doesn't ignore lock. Oh. Oh. I see. So in our ASM matcher types, no function types here. Define. I was already wondering before about the lock, but then I didn't think much about it. Okay, let's put lock here. So prefix lock. Prefix lock. Okay, so we have 4 symbols actually. Okay, that's fair. Let's give this a new spin. On that note, we need to do one more pass here over these things. Currently it uses these macros, but perhaps it should just use these string views. Maybe. Can I just put this here? Or maybe we could have both. We could have the string view and this, right? So here we could say lock It's kind of hard to read this way. So if we C++ FMT library string view. I would like to know how to pass a string view to the format library. Join. Boy, the documentation is huge. Holy shit. Okay, there's so much. I don't know how to search for what I'm looking for. Basically, I want to know how to use this for string view as prefix lock. But here the problem is this. But maybe it does it automatically. Yeah, I would since it's C++ function, it's not a C function. So this probably works. Yeah, this probably works. Because you can already pass an std string, right? And it accepts that. So I expect that this also works. Yeah. Let's revisit the other things that we have looked at. Function types. Yeah. Okay, let's search for unc. I mean, this is already bad enough. LLX. It's kind of horrendous, I have to say. Okay. Yeah. Let's leave this for now, though. Let's put it like so. Okay, let's see if now we get a better comparison. Oh, we got a crash again. Oh, it does actually not work. Wow. That is sad. That is sad. That is really sad. Why you cannot pass string view? This is really sad. I mean, there are sadder things in this, obviously, but huh? Did they never thought of this? Did they never thought of passing a string view as an argument? Maybe they never thought of this, but someone should have thought of this, right? Maybe it needs a different keyword here. Oh, right. We don't pass %s, we pass like this, right? S, right. It's not percent. Let's try this. Okay, that works now. Good, so result is, yeah, this is mismatching very well. Okay, let's look at this one in our watch. Okay, so we still got mismatches. Let's see. Okay, it still has problems with the lock. Why? Skip unknown symbol. It has lock in there. Why is it not? Skip unknown symbol. Skipped. In quotes. Let's put a breakpoint here. If str null point str char lock 131f. So if it finds this, then printf AA. Let's put a breakpoint in here. Okay, it does hit. In quote true. Okay. char is now lock 131f. So let's look at our instructions. So it's the JZ jump short, lock this. And on the other side, we have JZ short, also lock. So these should match, right? Let's see. Skipped, false. Skipped, false. Okay, why is it not skipping them? Skip, false, prefix, sub. Oh. Right, because we are currently at a quote symbol still. That's why. Aha. So here in quotes we have to do plus plus char. Ugh. In quote. Okay, so I think we simply need to increment char, both chars, to get past the quote, I think. Yeah, I think so. Let's try this. Okay, so now we are in quotes and we start with lock. Lock, yeah. So now it skips, yeah, true, true. And then it compares the quotes where we could yeah. Okay, something is not right. Because yeah, something's not right. So problem is when we skipped forward to the next quote, then this will skip over the last quote, but instead it should enter here. Oof. Okay, something is wrong with our algorithm. The question is, how do we solve this? Okay, so another solution here is we do +1 here. And here as well, +1. Huh? Stop debugging. Oh. That doesn't work. How do we do it? Skip unknown symbol. Okay, maybe we don't need this in quote toggle at all. Maybe we just say no, we need this because if the quote is ending, the symbol is ending, we don't want to keep on skipping things. No, this needs to be here. Okay, maybe break. Maybe this needs to be done here at the end. We remove it from here. And then in quote. Okay, so we detect that we have quotes, yeah. And then we set it to in quotes. And when we increment these, so we are one past the first quote. Okay, we are in quotes. Then we decide, okay, we skip unknown symbol, which will skip to the last quote. Let's test this here once more. Good. So we have quotes. We are in quotes. We skip that quotes. Okay, now we skip the first, we skip the second. And we are now located at the last quote. And then what it does, it compares these two last quotes and they are identical. And then it counts up here. But this is now a problem because then it won't flip this back here. Okay, so in the quotes, we check this thing. I don't know. I don't have an elegant solution for this. But there is a way to do this. I'm fairly confident. There is a way to have an elegant solution for this. I just don't see it right now. But it is there. It is there. Okay, we just need to think a little bit harder. We need I need some water. Okay. Okay, this is a surprisingly difficult algorithm. But probably just because I don't see the obvious answer. So we enter a quote, and if we are in the quote, we want to skip ahead, if necessary. But then we also want to know when the end is again. Skip, no. Ah. We can set in quotes. Maybe we need to put this in here, yeah. Like that. Because basically, if we have skipped, so we have skipped one side and then we skip also the known symbol ahead. We can also simplify this to if skip 0 or skip 1, then we know we will be at the end. So we say in quote false. And when we skip over the quotes, and then we'll be but then this is not correct. Because now we would increment to over the quote, and then here we would increment over the null terminator. So that's not right. Okay, so maybe we just put this here. And this and this. Yeah. Then let's put these guys back in here. And remove this. This could be correct. Let's see. Okay, in quotes. Skipped. True, true, skipped. If one of these skipped, we are no longer in quotes, false. And now it's it compares these guys here, the quotes. And then it's done. And we are not in a quote. Yeah, let's look at some more examples. Put a breakpoint here. So here we have another log. Okay, let's look at this guy. So this should be skipped false. And no skipping here, yeah. Okay, so we remain in quote true. So it will now compare it will now compare the strings of the symbols. And now now it does this unnecessarily again. In quotes. Okay, so in quote, this toggle is actually not necessary. We just want to know if we are in quote once. So we say okay, I think we simply have to put, let's comment this out, and this. I think we simply have to say if both of these start with quote. No, that's not correct. It's not correct because there still is an end to the quote. Quotes. We should probably have a continue here, so that if there is another quote following, like let's say you have quote quote, then if we do this, it would skip over it and then go to the next quote. So we should do this. If both start with a quote, we set in quote and then we continue, then it increments. But then what? In quotes. In quotes, skipped. Okay, so in quotes. We can make this an integer and we put it at 0 and we say in quotes if it's larger than 0, we set it to 0, otherwise we set it to 1. And then we say in quotes, if in quote is 1, that means we are at the beginning of the quote. And then here we set in quote 0. No. Yeah, in quote 0. This could work. Okay, let's see. Okay, in quote 1. Okay, we have here some symbol, yeah. Then it's not being skipped. In quote is 1. But we need to if in quotes is larger than 0, then plus plus in quotes that's Oh, because it's not 2. Let's be here then. No, that also doesn't work. Okay, so this should now flip to 1. And it does. Ah, but then it continues and then it's right. Yeah. Uh we are overcomplicating it, I think. I'm doing it too complicated. I know there must be a simple solution, but it somehow slips my mind. Okay, how about remove this garbage here again? Okay, let's take a step back. We hit quotes on both sides. We hit the quote. We know we are now beginning a quote because the first time, yeah, first time. Okay, first time we want to. Let's set this to -1 to begin with. So we hit the quote, then if quote is larger equals 0, then we set it to -1, otherwise to 0. else if in quotes is larger than 0, plus plus in quotes. Check if strings are entering a quoted symbol, quoted name, symbol name. Okay. So we have this and this. They are not the same. Okay, so in quote is now 0. Let's simplify this to smaller than 0, then 0, otherwise -1. Okay, so in quote 0, good. Then it continues. Now it skips over the quote symbol. And then in quote is now 0, so it increments here. And we are now at position 1 in the quote. And if we are at position 1, then we do this stuff here with skipping. Yeah. Okay, so far so good. Okay, and there was already a mismatch. Okay, let's check the next thing. Okay, here we have some unk. Let's see. So in quote, so it will have skipped the one, yeah. So it will also skip the other one, this one. Okay, so they both should end at a quote now, and they do. And we now say in quote -1. And now this one will compare the quote. And now it will skip ahead to this bracket thingy. Okay, that seems to work now. Yeah, no mismatch. Okay, let's take a look at another. Off critical section. Let's put here mismatch, no. Okay, let's look at the new result now. Let's see. Okay, we still have mismatches here. Let's see. It still counts as mismatch. I don't get it. I don't get it. Same thing. Why? Let's see. Okay, so in quote is 1. Skipped. Skipped. Okay, so both are being skipped. So we are no longer in quotes. -1. We are at the quotes at the end. No mismatch. Detail, no mismatch. Okay, detail, no mismatch. Mismatch, none. Instruction. Is invalid. Is jump. Okay, both are jumps. Oh, right. Because now we won't enter this here anymore. That's why. Yeah. Yeah, that is stupid. It's also bad because this means it won't check this here. Yeah. Yeah, yeah. Okay, so this is totally wrong here. We need to say I think we simply need to say how about we say here else if both are jump and the jump lengths don't match. So like if one is a jump and the other is not a jump, then it will already fail here, right? There will be mismatched bits. But if both are jumps, then we need to check if the jump length. Yeah, I think this is correct. Famous last words. And then we also do look ahead. Guess so. Yeah, I guess we can still look ahead. Okay, let's remove this. I think this is correct now. Maybe. So if one of these is a jump and the other is not, then this will fail. If both are jumps, then we still need to check if the relative jump length is the same. Okay, let's try this. Phew. This stuff complicated. Okay. Okay, let's look at this one now. Oh, everything is one now. Wow. Wow. Yeah, jump. Okay, now it recognizes it. But now it would be interesting to see if we get some where the jump length is different. Let's put a breakpoint here. By the way, we can be explicit and say is matching is false. It's okay if it's redundant. At least it's still explicit. Yeah, I think that's better. Is matching. Let's do that. Okay, let's put a breakpoint in here. Let's see if we ever get one hitting here. So here we have jump length 9. And here's 8. Okay. Is matching false. Look ahead. Is matching true. Okay. It now recognizes these as a match somehow. Interesting. I think that is because look at instructions matching. I think that's because oof. It's because we don't have this checked there. Let's do here is mismatch detail if not is matching. Let's remove this one here. Let's rename this to instruction mismatch bits. Is matching. Okay, I need to know what to do, but I'm not yet sure what the best way to implement this is. Yeah. Oof. Okay, what's the time? 3 hours. Yeah, I think it's time for a break now. Has been a while. Yeah, we are making progress, but it's a lot more buggy than I anticipated. Yeah, and I'm not so happy with this function down here. This one is atrociously complicated. So mismatch detail. Okay, what we are missing. We are missing one information here. In our mismatch detail, we should have information about the mismatching jump. Yeah, I think this is the angle. So currently we only compare the ASM text here, but we need to include, yeah, need to include some mismatch detail. So I think what we need to do is here we need to return the mismatch bits here. Mismatch bits. Yeah. Then we need compare ASM text. Yeah, I need to think a little bit more about this. Basically, here in our ASM mismatch, we also need to have the information about the mismatching jump length. Yeah, let's think about this in the next video. As my brain is already toast. Yeah. Okay. Yeah. I hope you enjoyed. I wish you a great day or night. Until next time. Goodbye.